to start. All right. We ask God for his guidance through this class. In Jesus' name, amen. And we were discussing about the various analysis that can be done.
Yes. Good evening, sir.
Yes, good evening.
Yeah, yes, sir. Sorry, the network is poor today. At least I can hear you now.
Yes. And the network wasn't really bad. I was having disruption.
Okay, all right.
That source.
Okay, thank you. Thank you, sir. I'm with you, sir. Thank you.
All right. So we looking at some other analysis here in continuation of yesterday. So in this case, there are two different variables plotted against each other. We have the weight by pounds plotted on the y-axis against the height plotted on the x-axis. And they now decided to split into male and female. The blue color standing for male and the red color for female. You can notice from the graph that in terms of weight, that the male tend to be heavier than the female. And in terms of height, that even the male tend to be taller than the female. So there is an association, there's a relationship, there's a strong correlation between weight and height. So there's a tendency that somebody who is taller is weightier than somebody who is shorter. So from the graph, you can easily make this assumption that because it is there, the data is there for you to see. So you can easily read the graph. You can also read from the graph that male are taller than female, and the male, sorry, let me not use male. The male is also weightier than the female. And you can also see that a male of 72, I don't know if the height is on meters or centimeters. So, but the male who is 72 is weightier, has the highest number of weight. You can see that two of them fall above the other ones here. So even the one that has the highest weight is above 200, then the other one is close to 200. All of them fall under males that are at the height of 72. So, and the weight is in pounds. Okay, the height is in inches. So male that are 72 inches, one of them has a very has a weight of more than 200, and one is close to 200. So you can easily read this graph that way. I hope you understand the graph.
Yes, sir.
Yes. And you can also see that when they were inserting these variables into x-axis, y-axis, they made gender as markers. So that's it. When we learn SPSS next week, we are going to see how to make categorical data into markers where you separate them, especially if they are nominal data.
Okay, sir.
So you set them as markers. They have two different colors. You can have a race, somebody is black, somebody is white. You can have two different sports. So those are nominal kind of data. All right. Now this other chart, okay, is the same as the other one. I just finished reading. You can see if we the in the data, this graph is called a scatter plot. This graph is called a scatter plot. All right. Let's look at this. We talked about the eye correlation. From the graph, what I can read is that there's a high correlation between height and weight, which means there is a strong correlation. So somebody who is shorter is likely to have a lesser weight, and somebody who is taller is likely to be weightier. So now let's see the correlation coefficient that they calculated. Let's see the value. Let's see if it is inside here. They've not calculated it. But we would have seen that the correlation would have been above 0.5. So it would have been a very high correlation. Okay, this is another variable, a variable that had to do with smoking habits. Okay, the variable that, okay, they are looking at pulse rate of those who ran and pulse rate of those who were seated. So the same people, you see that the same people participated in the two experiments, but that's for the experiment. As is that we are reading the analysis here. Now, those who ran and those who sat down, and this is their pulse rate. The mean pulse rate of those running is 73.60, and the total number of observation was 35, and the standard deviation is 11.43. Then after I don't know if this pulse rate was before activity or after activity. Sorry, before activity and after activity. It's what we are seeing here is that they say pulse rate 1 and pulse rate 2. So we will believe that this pulse rate 1 was before the person started running, and this pulse rate 2 is after the person started running. Same thing is before the person started sitting down and after the person sat down. So you notice that the pulse rate increased after somebody ran. And you also notice that it reduces when somebody sits for a long time. So you now have the data. So you easily read that data. And you can also see that they were evaluating only one variable of data, which is as the independent variable, which is the activity between the poles. So, and the dependent list with the outcome, which was the pulse rate 1 and the pulse rate 2. So in this case, I believe, okay, they were going to use the independent t-test, even though they have not done it yet. So remember I talked about the independent t-test that is used to separate activity. Sorry, not independent t-test. I talked about t-test, pair t-test that compares differences. That is the second one, not the independent t-test. The pair t-test that compares two different conditions, which one contributes more to increase in pulse rate in this case. So this is the kind of analysis you can go further in this analysis. As in, if I'm to work on this data, having this kind of having this variable, and I want to see which activity contributes more to increase in pulse rate. So I will use the t-test and pair t-test. All right. So the mean pulse rate appears to be higher after an hour. I said something like that, but unchanged after sitting. However, the standard deviation is large. So we may want to check that this increase is not just part of the inherent variability of the data. All right, test t-test. Okay, remember I already mentioned that if I'm the one working on the data, by presenting one variable to check the different conditions, I'm going to use the paired t-test. All right. Now, this is paired t-test that they are using, which definitely means that this analysis, the person knows what he wants to achieve. I hope you have gotten up to this point where they use the paired t-test. Are you able to understand and why they use the paired t-test? Hello?
Hello, sir. Sir, I'm back. I can hear you.
I said, do you understand why petitus is used here?
Sorry, sir. I was lost. I wasn't hearing you for about 5 minutes. I had to leave and join again. I'm sorry.
Okay. All right. I was talking about this data. So I was
Okay.
saying that the independent variable used here was the
Yeah.
activity between poles. And when they
Yes.
presented this data, this report, this summary of the report,
Okay.
talking about the mean, the number of respondents, and the standard deviation, the,
Okay.
the value. So I was like saying, this is a pet t-test that is going to be applied next. That the reason they are going to apply pet t-test is that they are going to look at the pulse rate given the first condition and the pulse rate given the other condition.
Okay. Yes,
So
sir.
in such a case, that is the reason they are applying the
PhD test.
test.
Yes.
Supposing the it was this independent place had to do with gender. It could have been the independent test. You understand?
Yes.
So that independent test would be to find out which of the gender contributes more to a higher pulse rate. You
I
understand?
understand. I
So
understand, sir.
when they now say activity between pulse, give two different conditions,
Mm.
as in I should be able to know which t-test to apply. You understand me
Okay.
now?
Yes, sir.
Because talking about two different conditions is different from talking about um, two different gender. Two different conditions will result in an ordinal data. One will result to a higher
Mm.
rating than the other.
Yes.
Whereas when you talk
Yes.
about gender, both
Mm.
of them are nominal. You just
Yes.
want to know which gender is contributing more to what you
Mm.
are speaking on. You
Yes.
understand?
Yes, sir.
So that was what I was saying there. So if
Okay. I got
you
it.
look here, they did
Okay, sir.
exactly what I expected. Understand? They did
Yes, sir.
the analysis using the paired t-test.
Okay.
Now, they first of all analyzed those who ran before running and after running. The pulse rate before running was 73.60, the mean pulse rate. Then the mean pulse rate after running is 92.51. This is the standard deviation, and this is the standard error of mean. Then for those that were seated, before they sat down, their mean pulse rate was 72.42, and after sitting for a while, they now had it dropped to 72.32. And you see the number of participants in the experiment. Are you there? You see the number of participants in the experiment. So that was it. Then look at the sample correlation. So there is a high correlation between increase in pulse rate um, and when you are running, which is 0.607. Then a high correlation in reduction of pulse rate when you are sitting. So as you sit, the reduction in correlation of sitting, there is always a high correlation to reduce pulse rate. So you can be sure that once somebody sits down for a long time, his pulse rate will drop. And once somebody runs, his pulse rate will go up. The correlation coefficient of 1 is very high, which is 0.923, which is that of sitting, which means when somebody is resting, definitely the pulse rate should drop. That's a very high correlation. I hope you are able to read that. All right. So that is for that. There's something else I would love to show us before we close for today and to resume next time, next week. All right. All right. I want to show us this. This is a way of obtaining data in experimental design without the respondents or respondents being correct. So this is a sample of what we talked about, randomized way of obtaining data. Now, this experiment was to get people to know how fluent are they with different languages. So instead of asking the person, are you fluent in so language? They were given pictures to name the item in any language, any 2 or 3 languages they understood. So by this, the people will now assist if they can speak the language. So sometimes whenever you design an experiment, we don't need to ask direct questions. Like in this case, they are using pictures. They want to look at language ability to speak the language. So you don't like say write in that specific language you want to assess them. You can just say the three languages you can speak very well: Spanish, Basque, and English. Then you give them pictures. Write the name of this thing in so language and make a statement out of it. By that you can easily use in assessing the person, the language capability. So there are lots of things like this online that is being used to obtain data from us. So whenever you are clicking something online or doing anything online or writing something online, there's always a possibility that data is being extracted from you. So this is what I want to show us. All right, you're welcome once again. There is this thing I actually want to show before we end today's class. Are you there?
Sir, I'm back. I'm
Okay.
with you now.
Yes, I said there's this I want to show before we end our class today. I talked about this yesterday, that most times we go online and we don't know the amounts of information and data we are giving to large corporations to use. This is a typical example. Now, when we started this class on experimental design, I talked about randomization, ability to obtain data without bias. Sometimes I might want to, I don't know how many languages you speak, but I know, given the part of the country you are, you definitely speak Hausa and you definitely speak Arabic. Which other language is your language? Hello, are you there? Network. Okay. Maybe we'll end today's class. Hello. Are you there?
Sir, I'm there.
Are you sure your network is going to carry? I just need like 3 to 5 minutes to round up.
Yes, yeah, it will, sir.
Okay.
Yeah.
All right. Why I want to show us this, we are talking about experimental design in this part of our program. So when we started this class, I know you were not there, but I mentioned about randomization, ability to obtain data without bias. Whenever we are online, either on social media or Googling or doing anything we are doing, we give a large amount of data. When I mean data, I don't mean browsing data. I mean information that is either used for or against us, or used in making decisions for other people. Now, nobody will come directly to obtain this information from you. This is where randomization and unbiasedness comes in. I know, given the parts of the country you are, that you probably speak Hausa, speak Arabic. Which other language do you speak?
Hausa, English, then small Arabic.
Okay. Which your indigenous language?
Hausa.
Hausa. All right. Now, I may want to obtain this data from a particular region, but I don't want to go directly to know to how fluent do you speak Hausa, how fluent do you speak English, how fluent do you speak Arabic. So I want to obtain this data, but I don't want you to feel as in, I don't want you to feel reluctant. I don't want you to give me a false information. So what do? I post pictures here. And I ask you to name these pictures. If possible, write a statement about this picture. We are using the 3 languages you can speak. Understand?
Okay.
You see all those data, this data, let me show you. You see this data here? Let me load the data. This data was testing language proficiency of a lot of people. And probably if these people were asked directly to tell us if they can speak these languages, they may have given us information that is not really accurate. But this data was obtained from them without them telling the researcher if they can speak the language fluently or not. But the researcher was able to extract whether they are fluent by percentage of Spanish, percentage of Basque language, percentage of English, by giving them pictures, asking them to name the picture. If possible, write a statement about the picture. So whenever you are online, there are a lot of things we do online we don't know that we are participating either knowingly or consciously or unconsciously. We are giving out very large amounts of information. So now, even though these people may have been aware of this experiment, but the way the experiment is designed is such that it cannot be biased and it gives randomization. Because if I cannot speak Hausa, I cannot name this thing in Hausa. If I cannot speak Arabic, I cannot name it in Arabic. If I cannot speak English, I cannot name it in English. I hope you understand. So this is what I want to show us before we end today's class. Thank you very much.
Okay, thank you, sir. Thank you, sir.
Good night.
Thank you, sir.